So this one is a really chunky question looking at the effect of marketing. And in particular, this city has passed a new law where cigarette companies can only advertise if they include shocking images such as smokers' lungs, terrible teeth, things that really put people off smoking. So before this law came into effect, health workers estimated that 30% of people smoked. Sometime after the first round of adverts with this on came into effect and had finished, they conducted a survey to find out if the adverts were having any effect. These adverts could either still be attracting smokers, or they could now be dissuading smokers and putting them off smoking. So they randomly sample 15 adults. When they analyse the data, churn it all through, they find there was exactly 2 smokers in that sample. At the 5% significance level, is there enough evidence to suggest there's been any change in the number of smokers? Either it's increased or it's decreased. Okay, so I always start by figuring out the distribution. Now there's 15 people, and there's a 30% chance of them smoking. So if things haven't changed, that this advert had no impact on people either way, there'll still be a 0.3 chance or 30% chance that people still smoke. So our null hypothesis is that the advertising has no impact whatsoever on the overall number of smokers. And mathematically, let's shorten this. So the null hypothesis is that the number of people who smoke is still at 30%. That the probability is 0.3. If, however, it has had an effect, so our alternate hypothesis is that the adverts had some impact on our smokers, on the number of smokers, then we're going to say, in that scenario, the probability is no longer 0.3. Now, what we can't do is do repeated, we can't do like 3 or 4 hypotheses down here. You've only got 2. Either the first one, you accept it, or you reject it. If you reject it, you take the second one. You don't have extra potential hypothesis. It's quite tempting to want to say, oh, it's gone up or it's gone down. We can't do it in this case. It's not what we're looking for. We're looking for if there's been a change. And therefore, we can't test that, because that means it's gone down, and this means it's gone up. We can only test if it's changed. So at the 5% significance level. So earlier, we were looking at cases where we had 5% down here, and we're saying, okay, if it fell in this region, we reject it. Outside, it's fine. Now, we still need 5%. But we need to be aware that this could be at either end of our spectrum, because it could have gone up or it could have gone down. So rather than 5%, we're looking at a 2.5% chance at either end of our spectrum. So it could have gone up or it could have gone down. You've got to acknowledge the fact it could be at either side of that. We call this a two-tailed test because we have 2 tails either end that our numbers could fall into. And what's nice is that these 2 bits are symmetrical. So when we test it, we're going to focus on one and assume it might be it's the same scenario in the other. Okay, let me go through this for you a little bit. So we decided on our hypotheses, which were HO, that it hasn't changed, it's still 0.3, and the alternates being that it has changed in some direction. We got the data. There's 15 adults and there's exactly 2 smokers. Conduct a test at this point. Oh, and that was obviously 5% yet again, but because it's two-tailed, that's 2.5% either end. Now, let's conduct a test. So, Our test will be as followed. Binomial distribution. Oh, Mr. B out there. Let's go in blue. So, binomial distribution. 15 people, 0.3 chance of smoking. We can only need to test one end. Okay, because you were going to accept the fact it could appear on either side of this. So let's just check the chance that there is going to be X is less than or equal to 2 smokers. Okay, whether this has gone down or up from previously. So is a fact that there's 0, 1 or 2 smokers, there's a chance of that particularly unusual compared to what it was before. And if you look that up in the table, you'll find it to be 0.1268. So 12.68%. Now this is significantly above the 2.5% target we set ourselves. So it'll be down here somewhere. Ish, don't really know where. This will be down, so we can actually say, well, it's not unusual under the 0.3 condition that you're going to get exactly 2 smokers, or 1 smoker, or 0 smokers. And again, we always test the inequalities. So we can't say it's had any effect either way. So we can say there is not sufficient evidence that there has been any change in the number of smokers. Key phrase here. We cannot reject the null hypothesis. So we tend to say either we can reject it or we cannot reject. We don't really tend to say, even if I did previously, we don't tend to say we accept something. You can't say either we reject that or we don't reject that. Just because it buys us a bit of like wiggling room, if you like. Make sure you always look at what you're asked to investigate. Is it that things have changed up, changed down, or might have changed either way? If it's might have changed either way, like here, it's a 2-tailed test, so you've got to have the tail either side. But then you need to look at one particular way. And accept it reflects both directions. Okay, I think that's enough for now. And good luck.